In the video about muscle anatomy, I presented an overview of connective tissue or fascia. In this video, we'll go over a little more of the details about fascia, specifically the deep fascia, which covers muscles and also connects muscles to each other. This is not my profession. I'm a martial arts, exercise science enthusiast. I provide references at the end, so check them out yourself. Fascia is very broadly defined and is often used interchangeably with the term of connective tissue. A more narrow definition of fascia is a sheath, sheet, or any number of dissectable aggregations of connective tissue that forms beneath the skin to attach, enclose, and separate muscles and other internal organs. Now, this definition is from the 4th International Fascia Research Congress that occurred in 2015. This is a more narrow definition of the one presented in 2007 at the 1st International Fascia Congress, which is that fascia is the soft tissue component of the connective tissue system that permeates the human body, forming a whole body continuous three-dimensional matrix of structural support. It interpenetrates and surrounds all organs, muscles, bones, and nerve fibers, creating a unique environment for body systems functioning. The interest in fascia extends to all fibrous connective tissues, including aponeuroses, ligaments, tendons, retinicula, joint capsules, organ, and vessels. So you see here the second definition is broadly includes almost every type of connective tissue or even vessels in the body, whereas the first definition is specifically talking about sheets of connective tissue that can be identified separately from muscles and internal organs. Given these definitions, there are some classifications that are somewhat agreed upon, and that's superficial fascia, which is the fascial connective tissue just below the skin, just below what's called the adipose or the fatty tissue beneath the skin. The deep fascia, which covers the muscles and connects muscles to each other, and this will also sometimes be included, also includes the epimysial fascia, which is the fascia that encloses individual muscles. Then we have meningeal fascia, which covers nerves, and then the visceral fascia, which covers the organs. So let's clarify two terms that are often used when speaking about fascia and connective tissue. And the first will be an aponeurosis or aponeuroses, plural, and as opposed to aponeurotic fascia. Now, an aponeurosis is a dense connective tissue that has a regular pattern, which means there's a defined or clear pattern to the fibers in the connective tissue, and these are often in parallel. An example of this would be in your Achilles tendon or in your knee ligaments, such as the ACL or MCL. So in an aponeurosis, the fibers are just going in parallel in one direction, and so this connective tissue is very strong in a single plane. Now, as a distinguished way to look at that as opposed to an aponeurosis is we have aponeurotic fascia, and this is also dense connective tissue, and this connects muscles to each other, whereas an aponeurosis generally connects a muscle to bone or bones to other bones in the example of ligaments. Aponeurotic fascia is sometimes described as having an irregular pattern, but if we look, if I use the example of the rectus sheath, which we talked about in the previous video, we had the external obliques going down to an aponeurosis in this direction, Then we had the internal obliques running parallel to that. And then we had the transversus abdominis going transversely and then meeting kind of more horizontally into that same aponeurosis as the rectus sheath. So in this case, so in Gray's Anatomy, the rectus sheath is referred to as an aponeurosis, but in other documents, other books, the rectus sheath is referred to as aponeurotic fascia. So this is just kind of a distinguishing point between two terms that are somewhat used interchangeably, but aponeurotic fascia is a bit more specific because we see here that the fibers are going in different directions that may look somewhat irregular, but when we step through it and look at the various layers, we see that there is a regular pattern to them. And then another difference here is that as opposed to a aponeurosis where the strength is in a single plane or single direction, a aponeurotic fascia is able to handle tensile mechanical stress in multiple directions due to the multiple layers and fiber directions. Aponeurotic fascia is found throughout the entire body, and some of the main or notable aponeurotic fascial sheets are the pectoral, which covers the pec major, lats, and deltoids, the brachial fascia, which covers the upper arm, basically from your shoulder down to your elbow, the antebrachial, which is your forearm down into the hand, the rectus sheath, which we mentioned in the previous video, and then on the posterior side of the body, opposite of the rectus sheath, is the thoracolumbar fascia, which is along the lumbar area and connects the lats, glutes, and trapezius muscles. And then we have the fascia lata, which goes from the hip down to the knee, so the upper part of the leg, and then the crural fascia, which is the knee down into the foot. And these are all aponeurotic fascial sheets in which we also have various muscles connecting, and so things like the IT band is basically a reinforcement of the fascia lata, which also connects to the glutes. Another connective tissue that's worth clarifying and distinguishing from aponeurotic fascia is the epimysium. Remember, the epimysium covers the muscles, and it's the connective tissue that covers the muscles, so it is part of it is classified as deep fascia. However, the epimysium and the muscle movement are indistinguishable from each other. So when the muscle contracts or lengthens, so does the epimysium, as opposed to the aponeurotic fascia, which connects muscles to other muscles. There's a loose connective tissue that separates the aponeurotic fascia from the epimysial fascia, providing a slide, and it's also referred to as a slide and glide between the two surfaces. So for instance, in the arm, the bicep can contract and move without independently of the brachial fascia. There's one more thing I want to mention. There's also referred to as myofascial expansions, and this is connective tissue which connects the muscles to the fascia. So an example, when we spoke about the rectus sheath, the pec major has fibers that go into the rectus sheath, from crisscrossing over the xiphoid process. And another key point is that the superficial and deep fascia are adhere at various points along the body. So an example of this would be the linea alba. There's images here from the functional atlas of the human fascial system. Here on the left we see the linea alba here, and if you remember, this is a point in which the deep fascia adheres to the superficial fascia. At this point, the linea alba. Now the superficial fascia in this picture is removed for this dissection. We see here this line up and down where everything is tied into from the right and the left. And we also see here the external oblique going to its aponeurosis. So all the fibers here you see going one direction and then tying into the rectus sheath here. If you look closely, you'll see the fibers here in the rectus sheath going in different directions. Particularly down here, you see here fibers going this way and this way in the rectus sheath. And then here on the right, there's a example of a myofascial expansion. Here the pec major is cut away and lifted. So this part here is the pec major. Here's the pec minor down here. And we see here this connective tissue going down here, tying into the rectus sheath. So now when the pec major is under, either contracts or is under tensile stress, you'll see there will be some tension relayed down here into the rectus sheath. All the information in this video is from these two references here, the functional atlas of the human fascial system and fascia, what it is and why it matters. I suggest to check these books out, read them for yourself, and try to understand the subject. If you're watching this on YouTube, I also have an IG, which I post some shorter videos and some of the training exercises that I do.